Is the triangle to the left an isosceles right triangle? So in order for it to be an isosceles right triangle, remember that isosceles triangles by definition have two angles that are the same measure and one angle that's a different measure. If it's an isosceles right triangle, the different measure is the 90-degree angle, and then the two measures that are the same are 45 and 45. So that's the question. Are some of these angles, are two of them 45 and is one of them 90? Statement 1 tells us that angle C equals twice that of angle 2B, but without twice that of angle B. Without any numbers here, we have no way of knowing whether we're dealing with like 60 and equals 2 times 30 or what have you, or 90 and 2 times 45. So without knowing for sure, statement 1 cannot possibly be sufficient. We can cross off statement 1 as well as answer choice 1 and answer choice 4, A and D. Statement 2 tells us that A equals 45. That's nice. But that's still not enough because it doesn't give us the other two angles. All we know is that B plus C will add up to 135, which is not enough to tell us that they are 90 and 45 respectively. They could be something else. So statement 2 also insufficient. We get rid of B. Looking at the two together, A is 45 and B plus C, so it has to be 180. A plus B plus C, how should I do this? A plus B plus C equals 180. We know that A equals 45. So B plus C, like I already said, B plus C equals 135. We also know that C equals 2B. So B plus 2B equals 135. 3B equals 135, and B equals 45. So now we know that A is 45, we know that B is 45. Because of this property of triangles where they all have to add up to 180, C must be 90, and the two statements together must be sufficient, and it is, in fact, an isosceles right triangle. Answer choice C.